Hello students, this is a supplemental video to lesson U5A04b, and in that video I used and applied the triangle angle bisector theorem. However, in that lesson I did not go over where that theorem came from, so hopefully I can show you where it comes from in this supplemental video. So let's take a look. So to start off, okay, you're given this triangle here, which tells you that we have segment XZ is bisecting angle X, such that angle WXZ and angle YXZ are congruent. And then as a result of this, okay, we're going to prove that that proportion holds true. Okay, that side length WZ over side length WX will equal to side length YZ over side length XY. It seems kind of odd that those two proportions would hold true as a result of the angles being congruent on either side. So let's take a look how we can accomplish this. So what we got to do first and foremost is we are going to construct two auxiliary lines. Whenever we do not know something, or whenever there's too little information to work with, okay, we're going to construct additional lines or put in additional things to serve to our advantage, where it doesn't really change the original problem statement. By me drawing those dashed lines there, okay, it doesn't really change the original problem statement because it really doesn't exist. However, it will help support some of the ideas and logic, okay? So I drew in those two lines, okay, extending segment XY and drawing a line from point W, okay, to that extension, so that we end up with a pair of parallel lines. Okay, so the intersection of the auxiliary lines form point H. What happens is, okay, that I know that angle R, as a result of this, okay, will be congruent to angle Q because of the fact that now I have a pair of parallel lines. I'm going to end up with a pair of corresponding angles. So they have to be the same. I also know that angle R is going to be congruent to that of angle P, again, because of alternate interior angles. So as a result, then I know that angle P and angle Q must be the same because of substitution. Wait a second. If angle P and angle Q are the same, then I can say that side length HX and side length WX must be congruent. And the reason for that is base angles or congruent base angles have congruent opposite sides, right? This was based off of the isosceles triangle theorem. Okay, so now that we have those two legs are congruent, the next thing I can say then is, wait a second. I actually have, I can apply the side splitter theorem, right? Because again, I recognize is WZ, right? This side length over here, right? Over YZ must be proportional to that of WX. I'm going to use a different color. Must be proportional to that of HX and XY, right? That must be true. So hold on a sec. If that is the case, and wait a minute, isn't HX equal to PX? I'm sorry, HX equal to WX? So I want to make a substitution. HX indeed is equal to WX, and that's because of substituting information from line 8 into line 9. So actually, the last thing that we need to do, okay, is we can establish then that WZ over WX will equal to YZ over XY using cross products. And that is our triangle angle bisector theorem.